Hello, hello, welcome back again. So this module here is module number 18, and we are continuing on with talking about states of consciousness. And this module specifically focuses on psychoactive drugs. So what are psychoactive drugs? They are chemical substances that alter perceptions and mood. So specifically looking at things, drugs that kind of change things in your mind and your brain. Something important to understand is substance abuse disorder, which is a disorder characterized by continued substance craving and use despite the fact that it can significantly disrupt your life and or certain physical risks. So if you look in the DSM-5, that is the Diagnostic and Statistical Manual of Mental Disorders, which we will definitely talk about later when we talk about clinical psychology. But basically, it's the manual that is used to diagnose different disorders. So these are the 11 different pieces of the criteria to potentially meet a substance use disorder. So if you want, you can take a second and look through each of these things, but they have to do with diminished control, diminished social functioning, hazardous use, and drug action. So the way the DSM-5 classifies them is that if you have 2 to 3 of those 11 indicators, that is a form of mild substance use disorder. If you have 4 to 5 indicators, that is moderate, and 6 or more indicators is severe substance use disorder. With drugs, there are two big things that could end up happening as a result. Actually, there's kind of three. Tolerance, addiction, and the third would be withdrawal, which I'll talk about in a second. But tolerance is basically the fact that as you continually use a drug, your brain kind of starts to get used to it, and then you end up having to need more and more of that drug in order to feel the same effects of it. So your brain becomes more and more tolerant of it, and then it's harder to have that desired effect from it. So you end up having to have more of it. Addiction then is highly reliant on the fact that we have tolerance, and that is a chronic disease of brain reward, motivation, memory, and related circuitry. So it's basically that your brain is telling you you absolutely need this thing in order to continue to function. And as I was saying, that can happen as a result of tolerance and building up. This tolerance to a specific drug can lead to addiction when your brain literally feels like it needs more and more of it. So, what exactly is addiction? How is it characterized? It's characterized by an inability to consistently abstain, issues with behavioral control, having cravings, not able to recognize significant problems in your behavior or relationships with other people, and a dysfunctional emotional response. So, basically, in some way, it is significantly disrupting your life, and you might not even be totally aware of it. So, kind of like I was saying, it's less that people actually feel like they want a specific drug, but more they, sorry, that they actually need the drug. So their brain feels like they want the drug more than they actually like it. So the person doesn't actually want it, but the brain does. So, as I was saying, how can tolerance then lead to substance abuse disorder? Basically, the fact that as you continue to adjust and adapt to the effects in the brain of the substance, you have to have more and more of it in order to experience that same desired effect. As I said, there's a third component here, and that is withdrawal. So withdrawal is the discomfort and distress that follow discontinuing an addictive drug or behavior. So basically, since your body built up this reliance on a certain drug, once you stop using it, it can have significant effects on your body. And a lot of times those can be just as bad as the drug itself, like as some of the experiences from the drug. So withdrawal can tend to be very, very extreme, which is what makes quitting certain drugs so difficult, and something else that makes drugs extremely addictive because withdrawal can be so unpleasant. So this slide here is also just talking about how there are some other kinds of addictions now as well, rather than just substance use disorder. There's also things like gambling, internet gaming disorder, and internet use addiction. We're kind of continually gathering more and more research about those things as they are becoming more prevalent, but they are not something that is so huge that we're going to talk about it right now here in this class. So with our psychoactive drugs, we have three main categories. Psychoactive drugs are either depressants, stimulants, or hallucinogens. So we are going to talk about exactly what that means and what drugs fall into each of those categories. And as this slide here says, it's extremely important that you know those three categories and the drugs that belong in each and what exactly that means in the brain, because you are very likely to see AP exam questions about these topics. So starting with depressants. Depressants are any kind of drugs that reduce neural activity and slow body functions. So at least the good thing about the names of depressants, stimulants, and hallucinogens is the effects are exactly what the words sound like. So depressants depress the functions in your brain. It slows down your neural activity and your overall body functions. So one kind of depressant that we have is alcohol. And what it does is it slows down the central nervous system, meaning the neural activity in the brain and spinal cord are depressed. So one of the really good things about talking about psychoactive drugs here is that it kind of helps to tie together all the information we've been talking about with the brain over the past couple of weeks in terms of neurons and action potentials and reuptake, neurotransmitters, all those things. Hopefully throughout this lesson, you'll see how those things tie together here. So we are, just as a quick refresher, if we are looking at the transfer of neurotransmitters between neurons, this kind of purple area here would be the sending neuron. It's the first neuron that we have, and then it's sending these little green dots represent neurotransmitters. It's sending those to this pink area here, which is the receptor neuron, the receiving neuron. And that little gap in between the sending neuron to the receiving neuron is the synapse. And also the action potential is that neural impulse that is sent that leads to the release of the neurotransmitter. So hopefully this can tie together as we continue to talk through each of these drugs. So specifically with alcohol, two neurotransmitters that are impacted are GABA and glutamate. And hopefully you can review these neurotransmitters here to remember that GABA is an inhibitory neurotransmitter and glutamate is an excitatory neurotransmitter. So how does that tie together with alcohol? With GABA, the one that's inhibitory, basically it means that when we have alcohol in the body, it acts as an agonist with our inhibitory GABA receptors. So something important to discuss here is the difference between agonists and antagonists. So, and in terms of drugs. So any drugs that are agonists mean that they are mimicking the action of a neurotransmitter. So when we're looking at these little holes right here of where neurotransmitters want to bind, the receptor sites, if it is a drug that is an agonist, it means it's going to, the simplest terms, it's going to be the same shape as whatever the receptor site is for a specific neurotransmitter. That way it can bind more easily. So whatever this green dot neurotransmitter would be, an agonistic drug would look very similar so that it would bind in the same way as that neurotransmitter. So alcohol is an agonist for GABA, which means it is going to mimic that effect and make your brain have even more inhibitory neurotransmitters in it. On the other hand, glutamate acts as an antagonist. So if agonists mimic the effects of a neurotransmitter, antagonists do the opposite. They block the effects of the neurotransmitter. So that might be that either they block the neurotransmitter from being sent to the other neuron or from being reabsorbed into the sending neuron with the process of reuptake. So that means that if alcohol is an antagonist to glutamate, it's preventing glutamate from exciting the cell. It's kind of dampening the effects of glutamate. So these kind of show the fact that it's an agonist for our inhibitory GABA and is an antagonist for our excitatory glutamate. That kind of can help you understand how in the brain alcohol is a depressant and it's actually slowing things down. And alcohol can also change the structure of the brain a bit. So you can look at these pictures here, but basically that it leads to enlarged ventricles, which is not a good thing. You don't want more of that fluid space in the brain. So again, alcohol can just shape the brain in different ways. And of course, as I mentioned in the last video for our module, it's extremely important, again, as you are nearing the age of driving and potentially nearing the age of legal alcohol use and everything, that you are thinking about its effects with driving. So if it's a depressant, if it's kind of mimicking the effects of an inhibitory neurotransmitter, that means that it is slowing down things like your reaction time and your ability to judge things. So remember that has to do with your prefrontal cortex. So it's really inhibiting your ability to make good sound judgments. So please keep that in mind. Your mind can trick you into thinking that you are able to handle things that you are not, because your brain is actually in a altered state of feeling kind of slower. So be very, very, very careful with these kinds of things. This is also just a little more information on the effects of alcohol, and that people tend to not realize how drunk they might be. And if they're sober, they might say, I would never ever drive when I'm under the influence of alcohol. However, a lot of people actually end up driving then because they're not aware of how much alcohol they might actually have in their system. Or even if they are given a breathalyzer and they do know, their mind still can't comprehend, like, oh, but I feel okay, so I must be okay. But that's not actually necessarily true. And alcohol can affect memory disruption and reduce self-awareness as well. Along with, we have expectancy effects. So sometimes just believing that you're consuming alcohol can cause us to act out alcohol's presumed influence. So what would that be called? You have to think back a little bit to Unit 1. What's it called if you are given something where you think it's a drug, but it's not, or some kind of treatment? That is the placebo effect. So if I'm in an experiment and I give you something that I tell you is alcohol, but it isn't actually, and you still feel like maybe you're intoxicated, that's the placebo effect in action. So next, under our depressants, our next category is barbiturates. And they are drugs that depress the central nervous system, yet again, because they're depressants, and they help to reduce anxiety, but they also impair memory and judgment. So they can be used to help induce sleep and reduce anxiety. But as I said, they can impair your memory and judgment, and can be especially potentially lethal if combined with alcohol, because that's just adding more and more depressants into your brain. Another category of depressants is opiates. And those are things like morphine and heroin. Those are all part of opiates. They, again, depress your neural activity, helping to lessen pain and anxiety. So it just kind of slows everything down yet again. And I want to show this next slide here. As we talked about with neurotransmitters, with endorphins, opiates kind of mimic what endorphins do, which is kind of helping to suppress any kind of pain that you might feel and increasing pleasure. But opiates can actually then, since they mimic endorphins, your brain eventually adjusts to that and responds in the fact that it makes it harder for the brain to then produce endorphins. So that means that you are going to need more and more opiates in order to get that pleasure and pain reducing effect, because your brain is no longer producing its own endorphins. So yet again, that's what leads to potential addiction. So this question here, slowed reactions, slurred speech, and decreased skill performance are associated with abuse of which drug? So a little helpful hint here is that there is only one out of all of these that we actually just talked about with depressants, and that is alcohol. So the other ones we're about to talk about in a second, but the correct answer here would be alcohol. Next category is stimulants. So again, we had depressants, stimulants, and hallucinogens. So we are on to stimulants. So they are pretty much opposite from depressants, as it might sound. They are things that speed up and obviously stimulate the brain in different sort of ways. They excite your neural activity and speed up your body functions. So one kind of stimulant that you very well may know of is caffeine. So if you ever observe someone who drinks coffee or has some soda with caffeine in it, that's kind of used to help keep you awake and maybe get you in the zone a little bit and just help hype you up a little bit. So another kind of stimulant though is nicotine. And nicotine is an extremely addictive psychoactive drug that is found in tobacco. So, different kinds of tobacco products include cigarettes, cigars, chewing tobacco, pipe tobacco, snuff, and e cigarettes, which is vaping. So, quick little side note here with e cigarettes or vaping. Obviously, we don't have a ton of research about the long term effect of vaping yet, since it's a relatively new thing. However, a lot of people tend to think that vaping is okay because it doesn't have some of the tar in it the way that like cigarettes might, which can cause cancer. However, it still has nicotine in it, which is highly addictive and can be very bad for your body. So it absolutely has other harmful chemicals in it as well. So vaping is not at all necessarily a safe alternative to other products like cigarettes. So again, cigarettes and nicotine is extremely addictive. So there's kind of a lot here about telling you how smoking can lead to decreased life expectancy in many different ways. Each cigarette takes about 12 minutes off of your lifetime. So just think about how many cigarettes some people might end up smoking. That is continually decreasing your lifetime. I think this is a really interesting fact here that eliminating smoking would increase life expectancy more than any other preventative measure. So, one of the easiest ways to increase longevity in the world is by decreasing people's use of tobacco and smoking. So, just something interesting to think about. It's something very much within our control potentially. Obviously, cigarettes can also be extremely addicting as well because it could be something that is seen a lot on TV or with other friends doing it. And yet again, bringing up the prefrontal cortex, remember it's not fully formed until somewhere around the age of 25. So that means that you might see someone else who's smoking and think, wow, that looks cool. And your brain hasn't fully finished developing to the point where it can reason, okay, but let me think about all the potential negative long-term effects here and maybe why I shouldn't smoke. Instead, we tend to see a lot of teenagers who do end up smoking because you can't necessarily see all the potential harmful effects that may happen later on. I'm going to skip over this quote. You can look at that on your own. And then this image here is just telling you some of the physiological effects of nicotine as well as it goes through your brain and bloodstream and everything. So you can check that out as well. Next, we have cocaine, which is another stimulant, and it produces a temporarily increased alertness and euphoria. So cocaine can enter the bloodstream very quickly, which gives you that rush of euphoria, and it ends up, though, depleting the brain supply of dopamine, serotonin, and norepinephrine. So we are back to talking about neurons again. So as I just mentioned before, remember, purple thing here is our sending neuron, pink is the receiving neuron, and we are sending neurotransmitters between the two. But then after neurotransmitters get sent, there's this process of reuptake where the neurotransmitters are reabsorbed into the sending neuron. So what does cocaine have to do with this? The way that cocaine works in the brain is that it binds to the sites that normally reabsorb the neurotransmitter molecules. So cocaine blocks reuptake of dopamine, norepinephrine, and serotonin. So as I'm saying, you can see here that we're pretending that dopamine is in this kind of block shape here. It is literally binding to that sending neuron, which means that any of those neurotransmitters, dopamine, norepinephrine, and serotonin, they're not able to have that reabsorption, that process of reuptake into the sending neuron, but instead they stay inside that synaptic gap, which means that you continue to feel that rush of euphoria and everything. And that's exactly what I was just describing there. So definitely make sure that you go back to module number 9 if you don't understand some things about neurons and neurotransmitters, because that is absolutely an important part of the AP exam. Our next stimulant is methamphetamine, and it's a very powerfully addictive drug that, again, stimulates the central nervous system, which has associated energy and mood changes. Over time, though, it does appear to reduce your baseline dopamine levels. So it's decreasing the amount of dopamine that you are like naturally producing over time. Some of the effects may include irritability, insomnia, hypertension, seizures, social isolation, depression, violent outbursts. So yet again, a drug that might seem kind of alluring at first and have some maybe good initial effects, but then can absolutely lead to some very damaging effects later on. And you can see this here. These two mugshots are of the same person actually, and they're just taken 18 months apart. But she's someone who unfortunately is addicted to meth, and you can see the huge physical difference in her in the first mugshot to the second one, just as the result of using meth. All right, and our last stimulant we have is ecstasy, which is also known as MDMA. Besides being a stimulant, though, ecstasy is also a mild hallucinogen. So it kind of falls in both of those categories there. So just make sure that you note that. And again, it produces a euphoria and sometimes like a social intimacy, but then can lead to harm to serotonin producing neurons and then cause some changes to your mood and cognition. So the way that ecstasy might work is it triggers a dopamine release, but then the other major effect is that it's releasing stored serotonin and blocking its reuptake. So it's giving you a lot of serotonin basically. And serotonin is one of those feel-good neurotransmitters. Because remember, if you don't have enough serotonin, it can lead to depression. So basically, ecstasy is keeping a lot of serotonin in your brain. And so you can see some of the research here of exactly what ecstasy does. You can look at those on your own. So which stimulant causes high energy and emotional elation, dehydration, and damage to serotonin producing neurons? That is the last one that we just talked about there, and that's ecstasy. All right, on to our final category of hallucinogens. So they are psychedelic drugs that distort your perceptions and evoke different sensory images that aren't actually there. So that's what it means by the absence of sensory input. It's not actually something that is there that you are seeing, but it's more something that's made up in your brain. And so that's what we just talked about with hallucinations. Hallucinations can sometimes give very similar images to things you might see with a near-death experience, where you're kind of have some kind of weird close call where you might almost be dying. Your brain might actually start to produce some hallucinations and everything. So LSD is one kind of hallucinogen. It's also known as acid. And it can sometimes lead to a feeling of euphoria, other times to detachment, and sometimes even panic. So there's kind of like a range of emotions you might feel with this type of hallucinogen. And their mood and expectations influence the emotional experience. But then generally we see that the hallucinations themselves amongst people tend to have some commonalities. Marijuana and THC is another kind of hallucinogen. It's more known as a mild hallucinogen. Instead, it amplifies sensitivity to colors, sounds, tastes, and smells. So for our hallucinogens, we had that a mild one is ecstasy, which is also a stimulant. A powerful hallucinogen is what we just talked about on this last slide, LSD, and then another mild hallucinogen is marijuana. So it can lead to this kind of euphoric high, but then it can kind of have, I'm sorry, my slide is in the way here. It can have other kinds of effects as well. So please definitely take some time to look through this chart here that summarizes all of those different drugs, and you can see here which types they are and some of the pleasurable and the negative after effects that they have. It's really important you know the categories that go with each of these. It's absolutely something that is frequently tested on the AP exam, so I highly recommend looking over all of those. Let's do this last question here. Which drug is incorrectly matched with its category? So which one doesn't actually belong with the category it says? And that would be letter A. Alcohol is not a stimulant, but instead a depressant. So please feel free to look at these following review slides here. Actually super exciting that that is technically it for Unit 2. Now that is all of the material we have for Unit 2. There is technically one more module in Unit 2, which is Module 19, and that focuses on hypnosis, which is a super fun and cool area to look into. It is technically no longer on the AP exam though, so it's something we're not going to spend a lot of time covering in class, but I highly encourage you if you want to check it out, read that module, feel free to do so, but it is not something that is going to be tested. So this is technically it for our content with Unit 2. Great job, everybody. Give yourselves a pat on the back, and I hope you have a terrific rest of your day.